All right, guys, fractions. Fractions are our friends. You don't use that? I disagree, but I don't know. What do I know? All right, so fractions. Today's just a review of fractions. Everything we do today, at some point, you've done before, okay? Maybe not in a while, might not remember, but we've done it. You've reduced fractions, you've added fractions, you've subtracted, you've multiplied, and you've divided, okay? So first, let's talk about the different kinds of fractions. We have something called proper fractions. That is a fraction where the numerator is less than the denominator. So for example, something like 3/4. Okay, that would be a proper fraction. An improper fraction then, if a proper fraction, the number on top is smaller, Asia, what do you think is happening for an improper fraction? Right, the numerator is going to be greater. So that's a fraction where the numerator is greater. Yeah, you can say bigger if you want. More, right? If you want. Use what vocab you like. So it's a fraction where the numerator is greater than the denominator. Who can give me an example of an improper fraction? Dallas? Sure. 3/2. 3/2 would definitely work. Good. A mixed number. That contains a whole number and a fraction. Since we're just kind of doing a really quick run through of fractions today, we won't do too much with mixed numbers, but it's still good to know. So if I gave you something like 3.5, right, that's a mixed number. Do those all sound familiar? Okay. Adding and subtracting fractions. So, just gonna dive right into it. Normally, I spend 2 days on fractions. I spend a whole day on adding, subtracting. I spend a whole day on multiplying and dividing, but since we started late, right, and we had those placement tests, we're a little crunched on time. So this is gonna be just like a speedy overview. Adding and subtracting fractions. Does anyone remember, can you just automatically start adding and subtracting fractions no matter what they look like? Yeah. I heard a couple yeses, I heard a couple no's. Oh, what matters, Jaden? The denominator has to be the same. Yeah, you got to take a look at them and see, is my denominator the same? Which number is the denominator? The bottom one, right? That number on the bottom, our denominator, has to be the same. If it's not, you got to make it be the same, okay? That's where we get common denominators, okay? Common denominators, our fractions have to have the same denominator in order for us to be able to add or subtract them. So in order to add or subtract fractions, they must have a common denominator, right? They both have to have a 5 on the bottom or a 6 on the bottom or whatever it is. So a common denominator is normally a multiple of both denominators. So for example, if you had a denominator of 2 and another denominator that's 3, what's 2 times 3? 6. So you could turn both denominators into a 6. So there's a few steps you need to remember. So when you change a denominator, you're probably going to have to multiply, right? But think about when you solve equations. If you multiply something on the left, don't you have to also multiply it on the right? Same idea is going to happen with fractions. If you multiply something on the bottom of the fraction, you also have to multiply the top of the fraction. Exactly. So remember, you must multiply the numerator and the denominator by the same number. Okay. And we'll get into some examples of that in just a second. Sound familiar so far? Okay. So let's look at these three different examples of adding our fractions. Do any of these have common denominators? No. So we're going to have to rewrite some of these first. So let me zoom in a little bit. Yes, Aiden, that is correct. We could use that. So let's look at this one. We have 1 over 2 plus 1 over 3. I got a suggestion from someone online, but Asia, what do you want to say? What are you thinking? 6 is absolutely correct. You have a 2, you have a 3, right? And a really easy way, if you're ever not confident, right? If you're like, I'm just not sure, take those two numbers and multiply them. 2 times 3 is 6. So you can turn them both into a 6. Now here's what I like to do when I rewrite this, because you don't want to forget to multiply something here. So what I like to do is I'm going to put a little equal sign. I'm going to put my fraction bars, and I'm going to put 6's under each of them like this. Okay? Because I got to turn my 2 into a 6. I got to turn my 3 into a 6. Is the top going to stay 1? No, right? If the bottom changes, the top is going to change too. So what did we have to multiply the 2 by to turn it into a 6? Asia? 3. So if I have to multiply the bottom by 3, what do you think I have to multiply the top by? 3. So if I multiply the top by 3, or I'm sorry, if I multiply the bottom by 3, I also have to multiply the top by 3. And what's 1 times 3? Alex? 3. So that's now a 3. Okay, let's look at the other one. I then changed my denominator of 3 into a 6, right? What did I multiply that by? Jaden? 2. So if I multiply the bottom by 2, what do I need to multiply the top by? 2. Yeah, if you prefer. Yeah. And then what's 1 times 2? 2. Yep, good job, Aiden. Oops, I can't type. All right, good. Now, here's where sometimes some mistakes happen. When we add fractions, do you gotta add everything? When you add fractions, do we have to sit here and add all of our numbers together? Only the top, right? The bottom's not going to change, because think of it like that's the number of pieces you have, right? If you have 6 pieces of pizza, it's not going to magically become something else, right? So all you have to now do is add the top. So what's 3 plus 2? 5. So our final answer is 5 over 6. And if you can ever reduce it at the end, you should. Is 5 over 6 something that can be reduced? No. So that is just good the way it is. How can you tell if something can be reduced, Jaden? Sure. Normally. It depends, though. Occasionally, but a lot less likely. How do you know if you have to reduce it? Yeah, if you can divide the numerator and the denominator by the same number, then it needs to be reduced. Okay, so yes, Dallas. Sure. So quick example here, guys, because I don't remember if any of these need to be reduced. So I just want to look at a quick example off to the side here. Huh? Yeah, I don't know if any of these need to be reduced in the first part. Number 2 does? Okay. I just wanted to see, because honestly, people mess up reducing sometimes, so I want us to make sure we do it at least once. Okay, so then let's go on to 2. We have 1/2 plus 3/7. What do you think would be a good common denominator for 2 and 7? Alex? 14, because 2 times 7 is 14, right? Okay, so I'm going to put my 14s on the bottom. Good. And now we got to figure out what we multiplied by. Make sure we multiply the top by the same thing. So 4, 2. Alex, what did you multiply 2 by? 7. So what do we have to multiply the top by? 7. And 1 times 7 is 7. All right, the next one. Bailey, what did we have to multiply 7 by to turn it into a 14? We did, yes. So that means we have to multiply the top by 2. Correct. 3 times 2 is 6. And then who do we add? Yeah. Do we have to change anything with the bottom? No. What's 7 plus 6? 13. So we got 13 over 14. Can that be reduced? Nope. There's nothing that goes into both 13 and 14. Okay. Oh, you were thinking that. Yeah, if you reduce that, you're going to be back to where you started, so you don't want to change that one. But you're right. If you like ended up with an answer of 6 over 14, you would definitely reduce that. Okay. Number 5, we got 4 over 9 plus 2 over 3. Now this one I like to give to you because there's a few different things you might pick as the denominator. Yeah, you could do 27, but you could also do 9. Do whichever one you want. 27 is a little bigger, so you might have to reduce. 9 is a little smaller. Now, if you look at this, everyone we've done so far, you multiplied the bottom, right? But why is 9 okay in this one? Why does it not have to be 27? Lynn? Exactly. 3 can go into 9. So we could leave the 9 the way it is if we want and only change the 3. Does it matter which way you do it? No, as long as you reduce at the end if you need to, okay? I'm going to stick with 9 just because I'm a big fan of using smaller numbers when we can. Uh-oh, what's happening? Hold, please. Okay, yeah, you might. Oh, we're in equation mode. I don't want to be in equation mode. Sorry, guys, 1 second. I don't know what just happened. No, it does not. Okay, there we go. I think I got it fixed. I was in equation mode and I didn't know how to get out. Okay, we're all better. Okay, so 4 over 9 plus 2 over 3. We're going to go with the 9 on the bottom. So put your 9 plus 9. So did we have to change the first fraction at all? Nope. Just throw your 4 back on top. And then for the second one, what do you have to multiply 3 by? 3. So if you multiply the bottom by 3, multiply the top by 3, and the 2 is going to become a 6. Add the top together. Yep, 4 plus 6 is 10 over 9. And you can leave it. Oh, where'd that go? You can leave it like that, Asia. You do not have to rewrite it as 1 1/9 unless you want to. It's completely up to you. I would leave it like this. Why do an extra step where you might make a silly mistake, right? 9 over 10 is a, or I'm sorry, 10 over 9 is a perfectly acceptable answer. Any questions on adding? We good? Okay. It's not meant to be super hard. It's just meant to be a refresher. So let's subtract. So subtraction is going to work the same way. Okay, you can't change your order or anything though with these. Order matters when you subtract. So we have 3 over 2 minus 4 over 3. What would be a good common denominator for 2 and 3, Alex? 6. All right, so we're gonna have 6's on the bottom. Bailey, what did we have to multiply the 2 by to turn it into a 6? The 3, right? So what do we also have to multiply the top by? Yeah, same amount. And 3 times 3 is? 9. So our first fraction became 9/6. Now we're looking at the 4/3. Corey, what do we have to multiply the 3 by to turn it into a 6? 2. So what do we need to multiply the top by? 2. And 4 times 2 is? 8. Good. When we subtract, do we need to change the bottom? No, just the top, okay? Still same as addition, right? Only subtract the top. What's 9 minus 8? 1. Yeah, you got 1/6. And that cannot be reduced either. Good. Number 2, we got 5/3 minus 2/9. What would be some good common denominators for 3 and 9? 9, because 3 goes into 9, right? Or 27. Okay, use which one you feel more comfortable with. I'm going to go with 9, because I like to use the smallest common denominator. So equals, we got a 9 on the bottom, minus, and then another 9 on the bottom. Lynn, what do we have to multiply that first fraction by to make it have a denominator of 9? 3. So multiply the top and bottom by 3, and the numerator should now be what, Lynn? 15. Very good. And then we got our 2/9. Asia, do we have to do anything with that fraction? No. Nope. Just leave your 2. Subtract. And Alex, our final answer should be what? 13/9. Very good. Can that be reduced? Nope. I'm disappointed in myself that I didn't give you guys more to reduce, but that's okay. Number 3, we got 7/8 minus 5/4. What would be a good common denominator for 8 and 4? Asia. We'll take a look at it. But 8 is a good idea because just 4, can you turn a 4 into an 8? Yeah. Jaden, what were you going to say? 8. Anyone have another suggestion? You could do 16. You could do 32. Okay. Pick whichever one you like. If you're doing this and you're like, I want to use 16, then use 16. Just make sure you reduce at the end. So put your equal sign. Let's put our 8's on the bottom. And Asia, we shouldn't end up with anything too weird, so let's see what happens, okay? So if I'm leaving my denominator as 8, then Corey, do I need to change my first fraction at all? No, just leave it as a 7, right? And then for the second one, Jaden, what do we have to multiply the second fraction by? 2. So multiply the top and the bottom by 2, and Jaden, the top's now going to become 10. Is this where you got confused, Asia? Okay. Okay, I see what you're thinking. You're getting thrown off because it's going to be a negative number. So with this one again, are you going to change the bottom at all? No, so just look at the top. What's 7 minus 10? -3, right? -3, so this will just be -3/8, like this. Okay, so remember with something like that, you're subtracting, right? And they're different signs, Asia, so you would do 10 minus 7 is 3, but you had more negatives, so it's -3. Okay? Technically, the whole fraction is negative, but you only want to put one negative, right? Because two negatives would make a positive. So just you can just put one in the front or with a 3, either way. Okay? Any questions on adding or subtracting? People at home, are we good with adding and subtracting? Okay. Excellent. All right. Yeah, multiplication and division. These ones we will have to probably do some reducing. So, multiplying fractions. To multiply fractions, you must multiply the denominators. Sorry. And multiply the numerators. And then always reduce or simplify, whichever word you prefer, if you can. So when we added and subtracted, once our denominators matched, did we have to do anything with them? Did we actually have to physically add or subtract the bottom of our fractions? No. Multiplying and dividing is going to be different. In multiplying and dividing, multiply the top by the top, multiply the bottom by the bottom. Did you guys ever learn how to cross reduce?
Yeah.
Butterfly, okay. Yeah, like reduce diagonally. I like to do that personally. If you prefer to reduce at the end, you can. But why work with bigger numbers than you have to, right? Smaller numbers easier. Yeah. Most of the time, yeah. So a couple things to remember. If I'm multiplying, right? If I have a negative times another negative, it is going to give me a positive. And if I have a negative times a positive, it's going to give me a negative, exactly. So, right, a negative times a negative is going to give me a positive, and a negative times a positive is going to give me a negative. Just some little things to remember there that people make silly mistakes on. You with us, Corey? All right, so let's just dive into this. We're going to multiply the following fractions. So we have 10 over 3 times 2 over 5. So how you want to start this is up to you. If you want to go ahead and just multiply the top by the top, multiply the bottom by the bottom, and then reduce, that's fine. I like to reduce first if I can, okay? So how I always double check these is I always double check up and down, and I always double check diagonally and see if there's anybody that can be reduced. So look at your first fraction. You just have a 10 over a 3, right? Can that be reduced?
No.
Okay, look at your second fraction. You have a 2 over 5. Can that be reduced?
No.
No. Now check diagonally, right? Like the butterfly. Yeah, right here, you have a 10 and a 5. Can you reduce a 10 and a 5? Yes. Does anyone know what you can reduce them both by? Alex? 5, right? Is 5 divisible by 5? Is 10 divisible by 5? Yes. So we can reduce both of those by 5. So what I like to then do is I like to cross out my number here, okay? 5 divided by 5 is going to give me a 1. 10 divided by 5 is going to give me a 2. Oh, sorry. Okay, and now I have some smaller numbers to work with. And I can just multiply. So just look at the top. What's 2 times 2? 4. Then go to the bottom. What's 3 times 1? 3. And what's nice about this is if I cross reduce properly, Do you have to reduce anything again at the end? No. If you did not cross reduce, you would have ended up with this, which is also fine, but you would just have to make sure you reduced at the end. 10 times 2 is 20, right? 3 times 5 is 15. And then what goes into both of those? 5. 20 divided by 5 is 4. 15 divided by 5 is 3. Do you end up in the same place? Yes. Do you maybe have bigger numbers to deal with? Yes. But do what you're comfortable with, okay? All right. Let's go over and look at number 2. Ooh, what am I doing here? There we go. Okay. Number 2. Let's look up and down. Can you reduce a 2 with a 5? What about a 2 with a 3? Anything diagonally? Nope. This one, it just is what it is, okay? But something you need to be careful with. Look at your signs. Yeah, we have a negative and a positive. A negative times a positive is going to give us a negative. And then just multiply. 2 times 2 is 4. 5 times 3 is 15. And then there was nothing to reduce at the beginning, so there's probably not anything to reduce now, right? Correct. All right. Number 3. Ooh, it's a little bit weird and different about this one. Yeah, one of them's a whole number. How do you make a whole number a fraction, Jaden? Yeah, you just put a 1 under it, right? Throw a fraction bar under it. Throw a 1 under it. Now, do you have 2 fractions? Definitely. Did you say something, Lynn? Oh. Is there anything that can be reduced ahead of time? 3 with 7, does that reduce? No, 1 with 1, they can't really get any smaller than 1, right? So just multiply across. What's 3 times 1? 3. What's 1 times 7? 7. And you're done. All right, last multiplying one. We got negative 1/2 times negative 1/4. Do those parentheses really matter? Not really. Parentheses in this situation can also just mean multiplication, and sometimes you'll see them when you have negative numbers. So, first thing, is there anything I can reduce? What do you see, Alex? 2 and 4. What goes into both 2 and 4? 2. So 2 divided by 2 is? That's okay. You were thinking 2 times 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. And now let's multiply across. Why is it going to be positive, Jaden? A negative and a negative equals a positive. You can put your positive if you want, okay? Or you don't have to at all. Do what works best for you. What's 1 times 1? 1. What's 7 times 2? 14. Are we done? Absolutely. Cool. Okay, so dividing fractions. To divide fractions, you must first change the problem into, possibly, yes. If you have mixed numbers, you might have to change it into improper fractions. But here's the thing. Dividing, yeah, look at you. Dividing kind of stinks, right? Dividing kind of stinks. So, but multiplication's not bad, right? So instead, we change our division into multiplication. So you must first change the problem into multiplication. Does that sound familiar, Jaden? Yeah. So here's my steps. We follow these rules called keep, change, flip. You're gonna have 2 fractions. You are not gonna change the first fraction. I guess if you guys would do this way. You're gonna keep it. You're gonna keep that first fraction. Then you're gonna change the division to multiplication. Okay, that's our change part. Then you're going to flip or like inverse or whatever the second fraction. We'll just say flip. We'll keep our terminology easy here. And then you multiply the fractions and simplify if possible. So when I say flip the fraction, this is what I mean over here. It's technically called the reciprocal. You guys remember hearing the word reciprocal before? Yeah. It sounds like a what? A doctor word. This is technically called the reciprocal, okay? It's when you flip a fraction around. So again, we keep our first fraction, we change our division into multiplication, and then we flip the second fraction, and then we just multiply like normal, okay? Because life is hard. Dividing fractions? This is one of the most basic things that people actually like use. Yeah, well, I don't know. Write a letter to the governor and tell him that you don't want to do fractions anymore. So, Jaden, if you're complaining about this, you're in for a wild ride this entire school year because it doesn't get easier. So, back at it. So, divide the following fractions. We got 1/3 divided by 1/2. So, follow your steps here. We are going to keep the first fraction. We are going to change our division into multiplication, and we are going to flip the second fraction and turn it into 2/1. So this is now 1/3 times 2/1, and then just multiply like normal. Anything we can cross reduce? Nope. What is 1 times 2? 2. What's 3 times 1? 3, and then we're done. That's it. It's just 2/3. 2/3. All right, number 2. We got -4/5 divided by 3/5. So follow our steps. What do we do first? Keep the first fraction. So -4/5. Then we change it to multiplication. Then we flip the second fraction and write it as 5/3. Good. Anybody we can cross reduce here? Yeah, the 5s. What can I change those 5s into? 1s, because 5. Yes, you would just have to keep the negative with you. So like you would change it into like -1 or something. So like here, that's why I put the negative with the 4. You won't mess with that until the very end, Asia. Okay. So 5, right? We can change. We can change that into a 1. And then the other 5, change that into a 1. And then we are going to just multiply across again. So first of all, I like to just go ahead and write your sign down right away, okay? What's a negative times a positive? A negative, and then we don't have to even worry about it, right? Because it's already there. So then what's 4 times 1? 4. What's 1 times 3? 3. So -4/3. Okay. No, I wouldn't. I would leave it like that, Dallas, because improper fractions are totally fine. You don't ever have to change them into mixed numbers if you don't want to. It's just another place. It's an extra step where you could make a silly mistake. It is technically still simplified. Yeah. Oh, well, high school's different. Oh, I don't know. But so now number 3, we got 2/3 divided by 5. I'm confused. Why am I confused? Dallas? Yeah, one of these numbers here is a whole number. but one of them is a fraction. So what we're going to do is put a 1 under the 5 to just easily turn that into a fraction as well. Well, technically you're not learning it. Technically you're reviewing it. You learned it a long time ago. We're reviewing this because then tomorrow we're going to solve equations with fractions. And if we didn't review fractions ahead of time, you would probably have been really confused. Promise me when I say that there is a method to the things I do. I don't just do them just for fun. So 2/3 divided by 5/1. So let's follow our steps here. We're going to keep the first fraction. So 2/3. Change the division into multiplication and flip the second fraction and make it a 1/5. Anything we can cross reduce? Nope. 2 times 1 is? 3 times 5 is? 15. So you got 2/15. All right, and then one more, and then we're done with fractions, and then Jaden can maybe stop complaining. Well, no, because then we got to do word problems. Oh no, we're actually not word problems today. We have word problems tomorrow. Don't worry, just for you, Jaden. All right, so I'm gonna add a word problem to the test every time Jaden complains. So we got -3/2 divided by -7/4. So let's go. First of all, the parentheses. Do they have to be there? No, because is there anything happening inside of them? No, they're just there to kind of separate the negatives. Okay, I'm just showing you different ways this could be written down. So you don't have to rewrite the parentheses if you don't want to. So tell me what we need to do. Dallas, what's the first thing I should write down? Yeah, write the first fraction down. We're going to keep it -3/2. Bailey, what do I do next? Well, I don't have to simplify anything yet. We're doing our keep, change, flip. So we kept the first fraction. What do we need to now change? What sign do we change? Into? Correct. Yeah. Yep. Change the division into multiplication. And then last step, Corey, what do I do with that last fraction? We kept the first fraction. Yeah, we do what? We flip. Yeah, we're going to flip it, and we're going to make it -4/7. Does it really matter where that negative is? No, just like put it in the front somewhere. Okay. Is there anybody that we can cross reduce? Yep, the 4 and the 2. What goes into both 4 and 2? 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And again, so like something like this, Asia, I remember you asked about the negatives before. Don't touch them. Just leave them there, right? And treat the negatives as a separate part of the problem, okay? So, because then, if you don't mess with them, you'll still be able to see, oh, there were 2 negatives, right? And a negative times a negative is going to make a positive. And you could write a positive sign if you want, or you don't have to. Now multiply. We got 3 times 2 is 6. 1 times 7 is 7. 6